Hi, Chemistry! This is our first new video of content, and the first topic we're going to be going over is polyatomic ions. What they are, how you use them, and how you identify them. So I'm going to be going through a slideshow today, and then I will put a list of common polyatomic ions that you can use and some practice questions as links to Google Docs in the descriptions. I'll also post a solution video in the next coming days going over the answers to those so you can check your work. I'd also go ahead and like to acknowledge my coworker in the background. That one sleeping on the couch is my dog Cody. All right, so let's go ahead and start talking about polyatomic ions and what they are. All right, so let's start with a quick review of how you name ionic compounds in the first place. Here's some practice questions, and the way you name ionic compounds is by saying the name of the first element in the molecule and then replacing the ending of the second element with "ide." So, for example, the first compound up there is going to be sodium sulfide. For naming ionic compounds, you can totally ignore the numbers. You're just saying what the element names are. So, that second one, hopefully you figured out, is calcium iodide. The third one is going to be beryllium chloride. And the last one is going to be barium carbide. It's okay if you said carbonide. Some of them are kind of strange, but this is something that we're going to continue to practice. And you have the internet, you can always look them up. So, the essential question of this PowerPoint and what we're going to be going over today is, what are polyatomic ions? And let's take a second to think about the root word of polyatomic and what it means so we don't get confused or bogged down in the big terms. So, the prefix poly, what are the words that you think of when you think about the prefix poly? Come up with a few examples. I've done this in class before, and people always talk about polygons or polytheistic religions, polymers. Sometimes like polyamory, like sister wives come up. And if you think about all of those terms and what they have in common, it's that usually they're referring to things that are multiples. So the prefix poly actually means many. So a polyatomic is two or more bonded atoms that move as a single unit, or multiple atoms that move around together. It's called an ion because ion is the term for a molecule or an atom that has a charge. So polyatomic ions are groups of atoms that stay together and move around with a charge. You do not need to memorize these. If you take AP Chemistry, there's going to be a list of up to 10 that I do ask people to memorize, but those are the common ones. If you look up polyatomics, you can find lists of 25 to 30. We are just going to work with the common ones. So, polyatomic ions, a majority of them are negatively charged, which means they're going to bond with things that are positively charged, which are going to be metals. Examples include magnesium sulfate, sodium nitrate, and potassium chlorate. And the way you can identify if something contains a polyatomic is because it's usually one metal ion bonded to multiple non-metal ions. So when you are naming molecules that contain polyatomic ions, you are going to say the cation or positively charged ion first. And a really good way to remember that cations are positively charged is remember that cats have paws, which is how I remember. So you're going to say the positively charged one first. That's usually the metal. And then you're going to say the anion last. And in the case of molecules with polyatomics, it's usually going to be the polyatomic. So if you look at the links in the description of this video, you should be able to find a link to a Google Doc that shows lists of polyatomics, so we can practice naming this one. If you look on the list, you'll see that SO4 is going to be the polyatomic named sulfate. So the first element is going to be beryllium, And then you're going to say the polyatomic, which is sulfate. So the name of that molecule is beryllium sulfate. The second one is sodium, and PO4 is phosphate, which means that one's going to be sodium phosphate. The last one, LiOH, well, the positive ion is going to be lithium, and then OH, if you look on your chart, is OH minus, so it's going to be lithium hydroxide. Naming. One last thing to talk about is charge. So we know that the elements in the tall column, so the S block and the P block, have set column. So the last thing about naming polyatomic ions we're going to talk about is how to name compounds with transition metals in them. Because if elements have a set charge, if they're in the tall blocks in the S block or the P block, we know what charge they're going to be. But transition metals in that middle section can have multiple charges, so you need to write the charge of the metal as a Roman numeral in the name. If you're not sure of the charge of the metal, because those can have multiple, you're going to use the charge of the polyatomic to find the name. So let's look at two examples here. We have PbSO4, which is lead sulfate. It doesn't tell you what the charge of lead is, but sulfate has a charge of -2. And in order for that overall molecule to be neutral, that means lead has to have a charge of +2. So when we write that, we would write it as lead, Roman numeral 2, sulfate. Just like that. Okay, let's try the second one. That one's copper chlorate. So chlorate has a -1 charge, which means in this polyatomic, copper is going to have a +1 charge, so we would write it copper 1 chlorate. All right, so let's talk about if you're going from the name backwards to actually writing the molecular formula. So reminder is that unless it's written with a charge specifically, which they usually are not, molecules are neutral, meaning the overall charge has to be 0. And one shortcut to figuring out what the molecular formula is going to be is that the charge of one atom becomes the subscript of another. So for example, here on the screen, we have potassium with a +1 charge and sulfate with a -2 charge. So that the number on the charge, dropping the plus and the negative, is going to become the coefficient of the other term. So the 2 charge from sulfate is going to come behind the potassium, and the 1 charge from potassium doesn't need to be written on the sulfate. So the overall charge for that one is going to be K2SO3. Subscripts for polyatomic ions are going to be written outside a set of parentheses. So let's work another example where we can see what to do if we're going to have multiple polyatomics in our balanced neutral molecule. So here's an example with calcium, which is going to be a +2 ion, and nitrate, which is going to be NO3 -1. So the 2 from the calcium is going to be the number of nitrate polyatomic ions you have, and the 1 from the charge of the nitrate is going to be the number of calcium atoms you have in your molecule. In order to write that we have 2 nitrate molecules, we're going to write a 2 outside of the parentheses to indicate that we have 2 of what is inside the parentheses, just like when you multiply in math. All right, so I will go ahead and post some practice problems in the comments. I think there's 13. I will also post a link to a common polyatomic ion list that you can use while working through these. In the next couple days, I'll also try to post a solution video so you can go ahead and check your work. If you have any questions, please feel free to either comment below or send me an email, and I'll get back to you as soon as I can. Stay safe, chemistry. Bye.